Hi, my name is Electronic Simon, but you can call me eSIM for short. I've been told to open with a joke. Why was the SIM card late for work? Because he was embedded. Okay, let's jump straight in, shall we? As you're probably aware, eSIM cannot be removed like a physical SIM card. It is software and hardware installed onto a soldered chip into the device. They both serve the same purpose, securing operator credentials to make calls and access the operator's network in a secure manner while protecting the user. But eSIM offers a few extra benefits. Purchasing and activating eSIM over the air, convenient global connectivity, reduce electronic and plastic waste. More exciting and accessible product design, hardware space-saving solutions, simplified installation and deployment, supply chain costs reduction, security and robustness solutions, and universal remote activation. All sounds pretty good, right? But how is this applied in real-world scenarios? Well, there are three eSIM architectures. The machine-to-machine architecture, the consumer architecture, and the IoT architecture. They are all designed by the GSMA to provision remotely the operator's profile, simplifying operator logistics costs, customer acquisition process, and keeping the same level of security as the traditional SIM for the end user. Let's start very sensibly at the beginning. In 2014, the GSMA published the machine-to-machine architecture. The M2M architecture is designed for devices that operate without user interaction and have no user interface. For example, cars or smart meters. The operator or service provider manages the profile. It's easy to become bogged down in the technical jargon, so let's see a real-world scenario. Here is a car with an eSIM on board. Thanks to the eSIM, the operator server, and the routing server, the operator profile has been remotely provisioned into the vehicle. This is called a push model, where the operator remotely downloads the profile without end-user interaction. If the vehicle has an accident, an emergency call profile will be automatically activated. The M2M architecture is not applicable for consumer devices such as a smartwatch, where the user interaction is a must. And so in 2016, the GSMA created the consumer architecture. The consumer architecture is designed for devices that require user interaction. For example, smartphones, laptops, tablets, and smartwatches. As you'd imagine, this architecture provides full control of the operator profile to the end user, and multiple activation of operator profiles to several operator networks. So our real-world scenario. Let's take a look at Zoe. Zoe has subscribed to a service from an operator. The operator server prepares Zoe's profile with the subscription details. The operator provides a QR code that Zoe can scan to connect her device to the operator server, so Zoe's profile is remotely provisioned. Thanks to the device interface, Zoe can now locally enable, disable, and delete her profile, or activate more than one profile to access the operator's network. So to sum up, thanks to the device interfaces, Zoe has full and local control of her profiles. The consumer architecture allows connectivity to a wide range of consumer devices and allows simultaneous mobile connectivity to different operator networks. And so, let's stroll along Architecture Avenue to our last stop. Created in 2023, this architecture, based on the consumer architecture, is used in network-constraint and/or user interface-constraint IoT devices. For example, an e-bike for tourists in Amsterdam, a wind turbine in the middle of the ocean.
Is it the IoT architecture?
Correct. This architecture is for IoT-constrained devices that lack a screen, or are in locations that are difficult to access. The operator profile is remotely provisioned into the eSIM without end-user interaction. But how are the operator profiles enabled or disabled? This is done by the IoT device manager that can remotely enable, disable, and delete the profile, acting as the end user as per the consumer architecture. As there is no need for manual user interactions, this architecture can simplify the deployment of IoT connectivity and reduce the time to market. and completely streamlines the remote profile management and provisioning process. So there endeth the lesson. 3 eSIM architectures optimized for specific sectors and users, each one carefully designed to simplify the eSIM solutions, making it easier for operators and their customers. Class dismissed. That's enough network for one day. And I ended with a joke as well.